good evening. Um, I just thought let me take you through what you need to know for your paper two. I did mention a couple of elements during class that are important, and I'll bring them up here. And just to take you through it, we're also going to just be looking at this paper two, which is a grade 11 paper. So basically, you need to know obviously everything that you've learned this year. And that excludes all the other elements that we've learned that are metric elements. So that excludes I was gonna mention some paper one stuff like patterns that excludes your geometric patterns and those type of things. But like thinking back, I don't think you've learned anything from paper two that is from metric. So yeah, I just wanted to start this conversation with that. So the first question obviously that you will always get in your paper two is a statistics question. What you need to know is how to draw your box and whisker. You need to be able to analyze this question here that says discuss the skewness of the data. You need to be able to analyze those questions and answer those questions. So whether it's positively skewed, negatively skewed, and so on. Yeah, and then obviously every other element that goes with statistics, you need to know how to solve for your mean, your standard deviation, your mode, your median, your interquartile range, your semi-interquartile range. You need to be able to calculate for outliers and all those things. So that's for the the ungrouped data. Then once we get into grouped data, you obviously need to know how to estimate the mean. That is very important. You need to know, if I give you a data like this and I ask you to estimate the mean, you need to know that it's different from how you would calculate it up here, and you need to be able to calculate it down here. And remember that one is where you're finding the other columns, which is your midpoint. So you put a midpoint column there, and you'd put a frequency times midpoint column there, and the total down there divided by the total of your frequency is gonna give you the estimated mean. So that is very important. Again, you need to know how to draw your ogive. And then once you've drawn your ogive, you need to be able to answer all these questions about your ogive. So if I tell you at this certain point, you need to be able to go on your ogive and find that certain point and give me the relating y value that comes from that certain point. Yeah, that's all on statistics. And then question three might be question two in your test, question three, but that's where your analytical geometry is going to start. What's important from analytical geometry is you need to know how to use those three equations, which is gradient, distance, and midpoint. So applying those three formulas is very important. You need to be also able to find inclination. You will most probably get a question about inclination in your paper two. You need to be able to know how to solve it. And another thing about this is when you're using the midpoint formula, you need to be able to solve for, let's say, LK, and this point here was given. Let's say the L was given, the end point was given, and you try to find midpoint. It's very easy, just substitute into the midpoint formula and you get your midpoint. But let's say the L and the K was given, so the L is given but the midpoint is also given. How do you find the end value? You need to be able to do that as well. And all these questions that follow, proving that something is perpendicular, solving both what you call these gradients and timesing them together to see if you get -1, to also find a certain point if something is a quadrilateral, and so on. So those types of questions you need to be very familiar with. And particularly when I taught you about triangles, and we talked about what an altitude is, what a perpendicular bisector is, and what's the other one? Altitude, median. Yeah, it's a median, altitude, and perpendicular bisector. So of those, you need to be able to understand which is which and how do you calculate these equations or these lines when given these different types of line, whether it's an altitude, whether it's perpendicular bisector, or whether it's a median. So yeah, just definitely go onto your textbook. You should see some explanation, and plus we did this in class, so you should have some notes on that. And yeah, it takes you to a triangle looking like this, and yeah, you need to be able to work with it, again remembering how to apply your formulas: distance, gradient, and midpoint, and obviously solving for an equation of a straight line. And then that concludes your analytical geometry, and then you go into your trigonometry. And trigonometry, I've mentioned a couple of things during your lesson. Number one, you need to know how to solve trig on the cast diagram. So cast diagram trig, and is this a question on cast diagram trig? Yes, it is. So if you're given something like this, and then it says using a sketch determine what is the value of something like this. So you need to be able to draw the Cartesian plane, draw the triangle in the correct quadrant, and obviously label the triangle. Which one is your opposite, which one is your hypotenuse, and which one is your adjacent. And you might need to do some Pythagoras there to solve for the r or the x or the y, whatever variable is missing in that triangle. And you need to be able to answer these questions here. Then you will get a question that looks like this, that I call trig in a triangle. So this also entails you drawing a triangle. The difference is that this triangle here won't be in a Cartesian plane. You just draw it like normal. If this is cos 42, you draw you'd write this p as a fraction, so adjacent over hypotenuse, which is gonna be your p over 1, and then you label your triangle, and then you solve for the one side, and you should be able to answer these reduction questions that follow from that. So yes, cast diagram and trig in triangle. Then you might not necessarily gonna have to prove an identity, but you might be asked to simplify something, and that's where you need to obviously apply the rules that you would normally apply when you are proving an identity. So yeah, you might get something like that. And then lastly, on trig, you obviously gonna get is this a trig equation? I think it is. Yes, it says sine is equal to a. Yeah, that is a trig equation. And yeah, lastly, you're gonna get a trig equation which you need to obviously solve. And yeah, that kind of concludes trig, the general trig part. And then you're gonna have some trig functions. So you're gonna be asked to draw a trig graph, and from that you're going to be given a trig graph and asked to analyze it. So yes, you need to be able to solve for amplitude, solve for period. You need to be able to solve all these miscellaneous things that we've discussed about trig graphs. Obviously drawing it is very important, but calculating those elements is also important. And then that will conclude the trig aspect of it. I've not included any what you call 3D trig, so you won't get a question that is similar to this or anything like that. So you don't need to really focus too much on 3D trig. And then that concludes the trig aspect of paper 2. And then you're going to go into the Euclidean geometry aspect. And in the Euclidean geometry, you're obviously going to get a question that wants you to prove a a certain, what do you call this, a certain theorem that you've studied. They are the big four, I would call them. There's one that looks like this, where you're asked to prove chord bisects, what do you call this? This is the chord to midpoint of a radius to midpoint of chord, or something like that. I forgot the actual wording of this, but that's one of them. Or you could get the angle at center twice at circumference one, or you could get the cyclic quad one, or you could get the 10 chord one. So those are the big fours that are always tested. So one like this, one like angle at center twice at circumference, or one like the 10 chord theorem, or one like a cyclic quad. So one of those is going to be given. And then moving from that, you might have a question like this that needs you to apply what you've learned in one of your theorems to solve for sides. And then there's obviously going to be an aspect where you're going to have to solve for to apply your theorems to actually solve for angles. And yeah, that will be a Euclidean geometry aspect. And yeah, that should conclude what is important for paper 2. Please also know your converses. So as much as I've shown you the actual theorem that goes forward, you need to know the converse of that theorem, the one that takes you back, right? So yeah, learn your converses as well so you can apply them correctly. And yeah, that concludes everything that you need to know for your paper 2. We obviously didn't do any volume or surface area questions, so you won't get a question like this, but everything that I've mentioned, those are possible elements that could pop up in your paper 2. I hope that helps, and yeah, thank you guys. Bye.